China,
China,
China, China,
China,
China,
China,
China,
China.
In August 2025, Thailand's cabinet made a decision that sent shockwaves through the global defense industry. After 8 years of delays, diplomatic standoffs, and technical hurdles, they approved the use of untested Chinese engines in a billion-dollar submarine deal that Germany had tried desperately to kill. This wasn't just about submarines. It was about the moment China proved it could outmaneuver Western sanctions and emerge stronger than ever. The story begins in 2017, when Thailand's Royal Navy faced a critical problem. Their aging fleet needed modern submarines to patrol the strategic waters of Southeast Asia, where tensions with neighboring powers were escalating. After an international bidding war involving South Korea, France, and Germany, China's shipbuilding giant CSOC won the contract with their S-26T submarine, a deal worth 13.5 billion baht, roughly $417 million for the first vessel. And exciting news, we're also working on a second channel covering China-US politics, Huawei chips, and everything about China's technology future. We've placed the link in the description below, so make sure to check it out and subscribe. But here's where it gets interesting. Thailand didn't just want any submarine. They specifically demanded German-made MTU-396 diesel engines, the gold standard for submarine propulsion. These engines were legendary in naval circles, whisper quiet, incredibly reliable, and used in submarines from Brazil to South Korea. The MTU-396 wasn't just an engine, it was the beating heart that would make Thailand's submarine nearly undetectable in the depths of the South China Sea. China agreed to the terms without hesitation. Construction began at their state-of-the-art shipyard, with engineers working around the clock to build what would become one of the most advanced conventional submarines in Southeast Asia. The S-26T featured air-independent propulsion, digital sonar systems capable of tracking multiple targets simultaneously, and noise levels so low, between 80 and 90 decibels, that it could blend seamlessly with ocean background noise. For comparison, that's quieter than many nuclear submarines costing 5 times as much. Everything was proceeding smoothly until 2021, when the project hit an unexpected wall. Germany, citing the European Union's arms embargo on China, a policy dating back to the 1989 Tiananmen Square crackdown, suddenly refused to export the MTU-396 engines. The embargo, designed to prevent military technology transfers to China, had been largely overlooked for decades. But now, with China's military rise causing anxiety in Western capitals, Germany decided to enforce it strictly. The timing couldn't have been worse. The submarine was already 64% complete, with millions of dollars invested in specialized infrastructure. Thailand had spent 8 billion baht on submarine docks, training facilities, and personnel development. The Royal Thai Navy had sent officers to China for months of training on systems that might never be delivered. As one defense analyst in Bangkok explained at the time, this wasn't just about one submarine. Thailand was looking at this as the foundation for rebuilding their entire underwater warfare capability. Suddenly, that entire vision was in jeopardy because of a European political decision made thousands of miles away. China found itself in an impossible position. They had a nearly completed submarine sitting in their shipyard, but without the German engines, it was essentially a very expensive piece of metal. The Chinese shipbuilders proposed an alternative, their domestically produced CHD-620 engines. But there was a problem that made everyone nervous. These engines had never been used in any operational submarine, not even in China's own navy. Thailand's military leadership was understandably skeptical. Admiral Somchai Jirathawat, speaking to defense officials in 2022, reportedly said, "We're not interested in being test subjects for unproven technology. Our sailors' lives depend on these systems working flawlessly under pressure." The Royal Thai Navy had built their entire submarine program around proven German technology, and switching to an untested Chinese alternative felt like an enormous gamble. The standoff dragged on for months. Thailand explored every possible workaround. even proposing to have the submarines delivered to Thailand where German engines could be installed locally. This would technically avoid Germany's export restrictions to China, while still giving Thailand the engines they wanted. But Germany rejected this proposal too, making it clear they wanted to prevent any German technology from ending up in Chinese-built military equipment, regardless of the final destination. By October 2023, the situation had become untenable. Defense Minister Sutin Klungsang announced that Thailand was canceling the submarine contract entirely, considering instead the purchase of a Chinese-built frigate. The decision sent ripples through the defense industry. China stood to lose not just a major contract, but credibility as a reliable defense partner. If they couldn't deliver on their promises to Thailand, other potential customers might think twice about Chinese military equipment. But China wasn't ready to give up. In May 2024, a high-level delegation of Chinese military and shipbuilding representatives arrived in Bangkok for what were described as intensive discussions. What happened in those closed-door meetings remains classified, but the results spoke for themselves. Within weeks, Thailand reversed its cancellation decision and agreed to move forward with the Chinese engines. The breakthrough came from an unexpected source, Pakistan. When Pakistan had ordered 8 Chinese S-20P submarines in a $5 billion deal, they faced the same German engine problem. But unlike Thailand, Pakistan had immediately accepted the Chinese CHD-620 engines, trusting in China's technological capabilities. By 2024, Pakistan's submarines were operational, and their performance data provided the proof Thailand needed. Thai naval engineers spent months in Pakistan, conducting rigorous evaluations of the CHD-620 engines in real-world conditions. They ran 200-hour continuous operation tests, subjected the engines to extreme stress scenarios, and even obtained certification from Lloyd's Register, one of the world's most respected maritime classification societies. The results were surprising. The Chinese engines not only matched the German MTU-396 in power and reliability, but actually exceeded them in fuel efficiency and environmental performance. As a senior Thai naval engineer who participated in the testing later explained, "We went in expecting to find compromises and limitations. Instead, we found engines that had been specifically optimized for submarine operations in ways the German engines hadn't been." The Chinese had clearly learned from decades of studying Western technology and had improved upon it. The final cabinet approval in August 2025 marked more than just the resolution of a submarine contract. It represented a fundamental shift in the global defense landscape. Germany's attempt to use export controls as a weapon against China's military industry had not only failed, but had actually accelerated China's development of indigenous alternatives. The CHD-620 engine, born out of necessity due to Western sanctions, was now positioned to compete directly with established European technology in international markets. For Thailand, the decision meant accepting a 3-year delay in delivery, with the submarine now expected in 2027 instead of 2023. But it also meant proceeding with a contract that would ultimately include 3 submarines for over $1 billion. Making Thailand one of China's largest submarine customers. The Royal Thai Navy would finally get the underwater capability they had been seeking for nearly a decade. The implications extended far beyond Thailand's borders. Other Southeast Asian nations watching this drama unfold saw that China could deliver on its promises even when faced with Western interference. Malaysia, Indonesia, and the Philippines all had their own submarine programs under consideration, and China's success in overcoming the German embargo sent a clear message about reliability and technological independence. The real shockwaves from Thailand's decision reached far beyond Bangkok's defense ministry. Within weeks of the August 2025 approval, intelligence reports began circulating in Pentagon briefing rooms about China's accelerated submarine production capabilities. What Western analysts discovered was deeply unsettling. The CHD-620 engine that Thailand had finally accepted wasn't just a replacement for German technology. It represented a quantum leap in Chinese military engineering that nobody saw coming. By late 2025, satellite imagery revealed construction at China's Jiangnan shipyard had expanded by 40%, with dedicated production lines specifically for the CHD-620 engine system. The facility wasn't just building submarines for Thailand anymore, they were preparing for mass production. Defense intelligence estimates suggested China could now produce 12 submarines annually using entirely domestic components, completely bypassing any future Western export restrictions. The strategic implications hit Washington like a thunderbolt. For decades, American policy had relied on choke points in global supply chains to limit China's military capabilities. If China needed German engines, American semiconductors, or European navigation systems, the West could theoretically control the flow of critical technologies. The Thai submarine crisis had revealed a fundamental flaw in this strategy. Sanctions weren't slowing China down, they were forcing rapid innovation that made China stronger and more self-reliant. A former Pentagon strategist, speaking privately to defense contractors in November 2025, warned colleagues that, "We've essentially handed China a masterclass in supply chain independence. Every embargo we impose forces them to develop indigenous alternatives that ultimately compete with our own industries." The Thailand submarine deal had become a case study in unintended consequences. Meanwhile, across the South China Sea, Malaysia's defense ministry quietly initiated discussions with Chinese shipbuilders about their own submarine requirements. The Malaysian Navy had been evaluating European options for years, but Thailand's experience suggested that Chinese technology could deliver equivalent capability at significantly lower cost. More importantly, Chinese suppliers wouldn't weaponize export licenses for political leverage. The ripple effects accelerated through 2026. Indonesia announced a preliminary agreement to purchase 4 Chinese submarines equipped with the now-proven CHD-620 engines. Brazil, despite its traditional ties to European suppliers, opened negotiations for technology transfer agreements that would allow local production of Chinese submarine components. The Thai submarine that had started as a single-vessel contract was morphing into China's entry ticket to the global submarine market. Behind the scenes, German defense giant MTU was scrambling to understand how they had lost control of a market they had dominated for 30 years. Internal company assessments obtained by industry insiders revealed the stark mathematics of their miscalculation. By enforcing the arms embargo against China, MTU had forfeited not just the immediate Thai contract worth 50 million euros, but potential future contracts worth over 2 billion euros as China's submarine exports expanded globally. The German government found itself facing uncomfortable questions from domestic defense industries. BMW, which owned MTU, reported to shareholders that Chinese competition in marine engines had intensified dramatically since 2024. The company that had once enjoyed a virtual monopoly in high-performance submarine engines now faced a competitor that could offer equivalent technology without the political complications of European export controls. By mid-2026, the geopolitical landscape had shifted decisively. China's State Council Information Office published detailed performance data for the CHD-620 engine, openly marketing it to international customers. The specifications were impressive: 15% better fuel efficiency than comparable German engines, 40,000-hour operational lifespan, and noise levels below 85 decibels. Most significantly, the Chinese engines came with a guarantee: no export restrictions, no political conditions, and no threat of supply interruption due to diplomatic disagreements. Thailand's submarine finally entered sea trials in early 2027. Nearly a decade after the original contract signing. The Royal Thai Navy conducted exhaustive testing in the Gulf of Thailand, putting the Chinese engines through scenarios that simulated everything from emergency surface operations to extended underwater endurance runs. The results exceeded expectations across every metric. Admiral Prachachart Sirisawat, Thailand's submarine program director, reported to Parliament that the vessel performs at levels comparable to any submarine in our regional waters, regardless of country of origin. The success of Thailand's submarine created a domino effect across Southeast Asia. Singapore's defense ministry, traditionally aligned with Western suppliers, began evaluating Chinese naval technologies for the first time. Vietnam, despite its complex relationship with Beijing, initiated quiet discussions about submarine modernization programs that could potentially include Chinese components. The region that had once been viewed as a natural market for American and European defense exports was rapidly diversifying its supplier base.
China.
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 China has indeed resurfaced a 158-kilometer stretch of the Beijing-Hong Kong-Macau expressway using only AI-powered drones and autonomous robots. This project involved drones surveying the highway to identify repair needs and robots executing the resurfacing work, all without human involvement on site.
At 5:47 a.m. on a foggy morning outside Beijing, 10 massive machines rolled onto China's most important highway without a single human operator behind their controls. What happened next would fundamentally change how the world thinks about construction forever. These weren't ordinary construction vehicles. Each one was powered by artificial intelligence systems so advanced they could make thousands of critical decisions every second while laying down perfect asphalt at highway speeds. In just weeks, this robotic army had accomplished something no country had ever attempted: building 157 kilometers of highway using almost entirely autonomous machines. The location wasn't chosen by accident. The Beijing-Hong Kong-Macau Expressway serves as China's economic lifeline, connecting the political powerhouse of the north to the manufacturing centers of the south. This is the same stretch of road that created international headlines in 2015 when it became the site of the worst traffic jam in human history. And exciting news, we're also working on a second channel covering China-US politics, Huawei chips, and everything about China's technology future. During National Day celebrations, over 750 million people were traveling when a bottleneck at a toll station turned 50 lanes into just 20. Cars sat motionless for hours, stretching back for miles in what media dubbed Carmageddon. That disaster taught Chinese leadership a crucial lesson. Their infrastructure needed to be smarter, faster, and more efficient than anything the world had seen before. The solution came in the form of the most sophisticated construction project ever attempted. At the heart of this robotic revolution was the SAP-200C10, a machine so advanced it defied everything engineers thought they knew about highway construction. This mechanical giant could lay down 4 lanes of highway simultaneously. Its 19.25-meter wide screed stretching across the entire width of the expressway. Unlike traditional pavers that require multiple passes and human operators constantly adjusting settings, this autonomous beast spread hot asphalt with surgical precision that human workers could never match. But the real breakthrough wasn't just one machine working alone. The entire operation functioned as a coordinated robotic ecosystem. Behind the massive paver came 6 13-ton double drum rollers that pressed the hot asphalt into place with mathematical precision. Then 3 enormous 30-ton rubber-wheeled rollers provided the final compaction, ensuring every square meter met exact specifications. Here's where the technology becomes truly remarkable. These machines weren't simply following pre-programmed routes like factory robots. They were making complex decisions in real time, analyzing road conditions, adjusting pressure and speed, and coordinating with each other through China's Beidou satellite system with centimeter-level accuracy. Think about that precision for a moment. These machines could place asphalt with the accuracy of a surgeon's scalpel while moving at construction speeds across uneven terrain. The artificial intelligence controlling each machine was constantly processing data from dozens of sensors. When the lead paver detected a slight variation in the ground beneath it, algorithms automatically adjusted the screed angle. When rollers sensed that one section needed additional compaction, they applied precise pressure without human intervention. Infrared sensors monitored heat variations in the asphalt. Pressure sensors tracked compaction levels in real time. GPS systems maintained position accuracy to within centimeters. A low-latency communication network allowed all 10 machines to share critical information instantly. The project was spearheaded by Sany Heavy Industry, one of China's largest construction equipment manufacturers, whose engineers had to solve problems that simply didn't exist until they attempted to remove humans from the construction process entirely. How do you teach a machine to feel when asphalt is properly compacted? How do you program a robot to detect obstacles while maintaining perfect formation with 9 other autonomous vehicles? The answer came through what Sany engineers call fusion self-sensing high-precision positioning. Each machine was equipped with multiple layers of sensors, cameras, and communication systems that created a 3-dimensional understanding of the construction environment. But safety represented the biggest challenge. Construction sites are inherently dangerous places, and removing human operators meant the machines had to be exponentially more careful. Each robot was equipped with electronic fences that created invisible safety barriers around moving equipment. Emergency stop functions could halt all operations in milliseconds if anything went wrong. Real-time obstacle detection systems used radar and cameras to identify potential hazards before they became problems. The most impressive innovation was what engineers called zero-edge rolling. Traditionally, human operators struggled to compact asphalt right up to the edge of roads, often leaving gaps or damaging curbstones. The robotic rollers solved this using advanced tracking algorithms that could follow the exact edge of pavement with millimeter precision. The economic implications are staggering. Traditional highway construction requires dozens of workers across multiple shifts with constant human supervision. This semi-autonomous approach dramatically reduced labor requirements while simultaneously improving quality and precision. The machines worked with greater consistency than human operators, required no breaks, and delivered more predictable results. Construction time was significantly reduced, though the full scale of efficiency gains is still being analyzed as the technology continues evolving. But the real game changer isn't just the technology itself, it's what this represents for the future of global infrastructure. China isn't planning to stop at highways. They're developing even more advanced autonomous systems for bridge construction, tunnel boring, and building assembly. The ultimate goal is creating a nationwide network of intelligent infrastructure that can operate with minimal human intervention. Other major powers are taking serious notice. The European Union has announced plans to study China's autonomous construction methods. Japan is developing its own robotic construction systems for the 2030 World Expo. Even the United States, despite ongoing trade tensions, is quietly researching similar technologies through the Department of Transportation. The timing couldn't be more critical for global infrastructure needs. The world needs to build more infrastructure faster than ever before. Climate change is demanding new types of construction that can withstand extreme weather events. Aging populations in developed countries mean fewer workers available for dangerous construction jobs. Autonomous construction potentially solves all these problems simultaneously. This project also reveals something crucial about China's approach to technological development. While Western companies often focus on software and digital innovations, China is systematically applying artificial intelligence to physical infrastructure. They're not just building smart cities, they're revolutionizing the construction methods that build those cities. The data from this groundbreaking project is already being analyzed for the next phase of development. Chinese engineers are studying every aspect of the robotic construction process, identifying ways to improve efficiency and expand capabilities. They're developing new algorithms that could allow even more complex construction projects to be completed autonomously. The international construction industry is watching with a mixture of fascination and concern. Major equipment manufacturers from Germany, Japan, and the United States are scrambling to develop their own autonomous construction technologies. The race is intensifying to see who can bring robotic construction to the global market first. But China has significant advantages in this technological race. They have the political will to implement these technologies at massive scale, enormous infrastructure projects to test them on, and a manufacturing base capable of producing the machines. While other countries debate regulations and safety standards, China is actively building the future of construction. The implications of China's autonomous construction breakthrough extend far beyond highways and asphalt. What happened on that foggy morning in Beijing represents a fundamental shift in how nations will compete for technological supremacy in the coming decades. The robotic fleet that seamlessly laid 157 kilometers of highway wasn't just demonstrating construction capability. It was sending a message to every major power about China's commitment to dominating the infrastructure revolution. Within weeks of the project's completion, intelligence agencies across Washington were analyzing footage of those 10 machines working in perfect coordination. Pentagon officials recognized immediately that the same artificial intelligence systems guiding construction equipment could be adapted for military logistics, autonomous supply chains, and rapid deployment of military infrastructure in. The timing of China's demonstration was no coincidence. Just 3 months earlier, President Biden had signed the Infrastructure Investment and Jobs Act, committing $1.2 trillion to American infrastructure over 5 years. Chinese leadership watched as American politicians debated funding mechanisms and environmental reviews, while their own robotic construction crews were already reshaping landscapes. The contrast couldn't have been starker. America talking about infrastructure while China was revolutionizing how infrastructure gets built. The global construction industry began responding with surprising speed. By December 2023, Caterpillar announced a $800 million investment in autonomous construction technology, directly citing the need to compete with Chinese innovations. European construction giant Liebherr followed with their own autonomous program, while Japanese manufacturer Komatsu accelerated development of AI-powered excavators and bulldozers. The message was clear. China had forced the entire industry to embrace automation or risk obsolescence. But the real disruption was happening in developing nations where China's Belt and Road Initiative operates. Traditional infrastructure projects required flying in hundreds of foreign workers, establishing temporary housing, and navigating complex labor regulations. Autonomous construction promised to eliminate most of these complications. Chinese companies could ship robotic construction fleets to Pakistan, Kenya, or Indonesia, and begin building immediately with minimal local workforce requirements. The economic mathematics were becoming undeniable. A senior economist at the World Bank calculated that autonomous construction could reduce infrastructure costs by 40% while cutting project timelines in half. For developing countries struggling with massive infrastructure deficits, Chinese robotic construction represented a potential solution to decades of underdevelopment. Traditional infrastructure loans from Western institutions often included requirements for local labor and environmental standards that significantly increased costs and complexity. China's autonomous approach bypassed many of these constraints entirely. American policymakers were growing increasingly concerned about the geopolitical implications. The concern wasn't unfounded. Countries that adopted Chinese autonomous construction methods would likely become dependent on Chinese technology, spare parts, and technical expertise for maintaining their most critical infrastructure. The technology itself continued evolving at breakneck pace. By early 2024, Sany Heavy Industry had developed what they called swarm construction capabilities, where dozens of autonomous machines could coordinate across multiple simultaneous projects. These robotic swarms could construct airports, ports, and industrial complexes with unprecedented speed and precision. Each machine learned from the experiences of every other machine in the network, creating a collective intelligence that improved with every project. The implications for global labor markets were staggering. Construction employs over 100 million people worldwide, with many developing economies heavily dependent on construction jobs for economic growth. Autonomous construction threatened to eliminate millions of these positions while concentrating technological capabilities in the hands of a few companies, primarily Chinese ones. Labor unions across Europe and North America began organizing against what they termed robotic colonialism. Meanwhile, China was quietly testing even more advanced applications. Satellite imagery revealed autonomous construction projects in the South China Sea, where robotic fleets were building artificial islands and military installations without human operators. These projects demonstrated that autonomous construction could operate in the most challenging environments, from remote deserts to contested waters. The strategic implications were profound. Nations with advanced autonomous construction capabilities could rapidly establish infrastructure anywhere in the world.